Okay, so let's see what we're going to do today. So today we're going to continue our journey building a warehouse using effect. And last time we described all the things, all the entity that are involved in our applications. Yeah. And we started also scheming out few helpers, member, a product, a unit of measure, the concept of a warehouse. Yeah. And today we're gonna start tackling how we want to shape the request between the server and the client. And also we're gonna start maybe building some part of the server that will handle the requests. Okay, so let's see. Okay. So last time we were trying to describe the kind of the APIs we want to use for describing requests between server and the client. And the kind of the APIs that we want to use are kind of like this. We want to be able to define first what is an aggregate. For example, an aggregate is the kind of an entity. We have the products, for example, and then we will describe messages for the aggregate. And messages can be either a command or queries. The basic difference is that we want to know if we can batch a list of requests to the server, and we can only actually batch queries. And for commands, we won't batch them because batching them may result in a different order of the commands, and commands applied in different orders may result into different things. So we hypothesize that we can use these kind of APIs, trying to build these APIs, but then Maxwell came on stream and actually suggested something very interesting. That is that maybe instead of defining these extend product.aggregate, we can take advantage of the already built-in schema tag request and instead have something like uh, um, product aggregate dot metadata fields, and these will automatically inject some common fields that are common for all the requests for that aggregate. And what are those metadata fields? Those metadata fields basically are the ID of the current request, and that can be the ID of a message for query or the ID for a message of a command. So that if the network request fails, we can just retry again the message, and the server will know if, for example, that's a command, will know if he already have seen that command, or if it's a new command he have never seen. And in that case, well, we need to perform it. And we also provide in here two things that are the aggregate root and the aggregate ID. I stole those names, but I don't want actually to fully adopt the concept of an aggregate. And by aggregate root, I mean a set of entities, like for example, a product is an aggregate root. And inside of product, you may have many products because the product is the kind of aggregate you have. But then you need to have the aggregate ID because you need to decide if it's product number 1 or product number 2 or whatever. Okay, so let's see. We will start by saying that maybe we can use something that like product aggregate dot metadata fields. And that is what we described last time. And the nice thing is that this metadata fields is built in a way such as when I want to make a new message, for example, in here, you see that the make constructor is smart enough to understand that the aggregate root here, if I try to make, for example, change a dot make, we see that the aggregate root is optional, and if not provided, will be defaulted by the products. And that's because we are finding a products aggregate message. And that's really nice. So let's go back to this kind of implementation and try to expand this more. So maybe we want also to, as said before, describe which kind of messages are request and which kind of messages are request comments and which kind of messages are queries. So we need to provide a field that will say if that is a message of type query or type comment. And we can do that by trying to attach a field into the payload that will not be present in the encoded form, but will be present in the actual runtime version of the type. So let's do that by defining things like message kind, maybe. And this message kind can be the leader that can be either query, maybe comment, or query. Oh, right. This is the type. So we need to do schema.literal query or comment. Okay. No, sorry, schema.literal query or comment. That was right. Okay. It's complaining because we need to provide here and now. You can see that the schema, this is the type we want. And we need to attach that into the aggregate metadata fields, saying that message type can be one of those. But if we leave that as it is right now, the message kind, sorry, not type, we will see that if we go back to our scratch and try to say, okay, I will provide you a message ID, message 1. I will provide you an aggregate ID, which is product ABC. I will provide you also a new name, which is this is the new product name. We will see that it's still complaining. It's still complaining because we have the message kind in here. But as we said, we want to have only this type on the actual type. We don't want to provide it. So we can try something like I want to use message kind in schema dot optional tool required. We can try this. And we will say that we don't want that into the encoded version, so it will be never. And it will be at runtime type if there are query of comments. And now we need to provide the function that will basically encode and decode. And we need to encode either to query or command and decode to never. So the encode is very easy and will be just option dot none. We need to import option from effect. everything as option, drawn effect, option. Okay. And now we need also to provide the decode function. And here in the decode function, we will basically need to return either query or command. So let's say that we want to just try it as a return command. Okay, we see that this is the actual type signature. We want to insert into our message metadata fields. It's not this anymore, but it's this. Okay. This is the new definition of the message kind. So the older one where we tried is not right anymore. Okay, let's go back and see our resulting API. Okay, we still have a problem because it's saying that he wants again the message kind. Let's check out type encoded equals schema dot type path change radically with schema. The encoded type is the encoded will be okay, read only, message kind never. Perfect. So what are you missing in here? There's a symbol to kind. Oh, right. It's oh yeah. I see. The thing it's complaining is that I want to attach that on the runtime type, but that will break. Yeah, because the problem is that the make signature uses the runtime type. So yeah, we cannot use this way. We should find another way to do that. But yeah, let's try another way. Let's maybe try to do something like optional to required that will put this, but this won't work because now we are obligated to put the message kind in here, but I don't want to put the message kind in here. So another suggestion that Maxwell said is that maybe we don't care about having type information about which are the queries and which are the comments. Maybe we just want to put an annotation on the schema saying which kind of message is, and then use a custom interpreter to extract that. So let's try that approach instead. So we won't put any additional types in here. Okay. So now we are back to the previous implementation. We can now message is perfectly fine. And now we need to change and we need to define in here maybe things like export const create message type annotation type ID equals symbol dot for, and for now we can use this. Okay, so we are creating a unique symbol, and then we want to create a function that attaches an annotation to any given schema. So let's say that export function as query that takes in an A, E, R schema of A, E, R, or even better, A extends schema dot any or all. That is basically, that means that we want A to be any schema that can be defined by fx schema. So the schema will be of type A, and we'll return back A, but return schema dot annotations. And here we can say something like we want to attach this aggregate and say that the type is query. Okay. Here, what are you complaining about? The is not a similar of the tennis scheme. Oh yeah, schema. Oh yeah. Oh, I see. Yeah. That's fine. We can also use return use schema annotations and use these annotations. Yep. And attach those to our schema. Okay, that works. Yeah. Okay, and now we can do the same thing as command, and we'll say that its type is command. Perfect. And now we want to create functions that will basically inspect the annotations and see if those are queries or comments. It's possible to is query, and we'll say that A extends schema dot schema all schema is A, and we can start by say schema is got annotation. Oh right. We need to import everything as AST from effect schema AST, and that is because AST annotation. Here we have the functions to get all the annotations, and we can say get annotation or aggregate message from what schema is schema AST. Perfect. And we'll return an option, and we then will say dot pipe option is some, and we need to import option obviously. Insert option here. Option is some. This will return a boolean whenever the annotation is present or not. But maybe what we also want to do is saying that the option dot flatness and say if the value if the kind equals query, and we will say option dot sum, or maybe we will say option query, and we will just not kind of query. Okay, so if the kind is query, action get or else calls. Okay, so this function will get the annotation from the schema est and check if it's a query. If it's a query, it will return true, and if not, it will return false. Same thing. Say is comment, and we'll leave our type comment. Okay, let's try to do some tests, maybe. But before, we need to check this aggregate root. Okay, we will have ID, message root, message ID, yeah. And I was thinking that maybe we, instead of just spreading things in here, we can maybe do something like changing a little and say things like product aggregate dot query. Okay. And this will return the query payloads. Yeah. I like this more. Yeah. I prefer this indeed. Yeah. So let's try to change product name. This obviously will be a command, not query. But let's first fix our examples so we have something to try. So this rename symbol, there will be change product name. Okay, it will be a command that will take the new name, and we will also have other things such as we don't need those anymore. Okay, and we can do things like get product name, or maybe read product name, product name. This will be a query and won't have any parameter. So these are the API I'm trying to achieve. And let's see here now in aggregate root. Okay, this is aggregate root metadata fields, but instead of returning metadata fields, we can do something like here we need to create query, which will be a function that given some basic field, some basic payload, extends schema struct fields. Today will basically return the payload, or payload will basically return the same thing. So payload and the additional metadata fields. Yeah, I can see this working. Yeah, and the same goes for comment, query and comment. Yep, that could be the same. Yep. Right now, obviously, is complaining because we need to define that. But if we now check this, yeah, and let's see, change product name dot make, just to see how the developer experience is. Oh yeah, that's nice. Yeah. Dot encoded. Yeah, look at this. Oh yeah, definitely. Okay, so now we need to actually implement those. So those are basically two functions that can be implemented by saying basic payload equals payload and basic payload by payload extends schema dot text dot fields. Okay, and we will return an object that will extend the basic payload here, here. Okay, and this is the function that will create our query. And this can we name maybe attach metadata payload fields. Yep. And now this is attach metadata payload fields, and the same goes for command attach metadata payload fields. Yep. Okay, that works. And let's see here. Okay, perfect. No complaining about types. Perfect. That's what we want. And if we look at the encoded, that's perfect. Okay. The only thing that we are missing now is to actually attach somewhere that AST that says if the request is a query or a comment. And we could do that theoretically in here. So let's try to maybe import everything as aggregate message from aggregate message. We could attach that dot pipe aggregate message as command. But the thing is that if we do that like this, we break TypeScript, because TypeScript now thinks that the type recursively references itself, and that's always fun. So we cannot do that. We need to attach that annotation somewhere else. And we have a payload. We attach things into the payload. So maybe we can decide that on one field of the payload that we attach, for example, we attach an ID field, we could say that on the ID fields, we also attach the annotation that says if the message is a query or a comment. So let's try that. So here we will say now that maybe instead of putting that in here, this is as comment, yeah, as query. So here we can now go back to our aggregate root and define first query equals. I'm not sure if we want maybe to do that to maybe we can do that like this. Let's see. Message point in the aggregate message aggregate message kind. Yep. And then aggregate message kind, we will use that to create a function that given the payload. Okay. So here, now we need first to define, you need to import the aggregate message module from here. So import everything as this from this aggregate message. Okay, and now we have it. And then here we can say export type aggregate message kind. That can be either a query or a comment. And then we can create like export function with aggregate message kind, and we can just copy this here and saying message kind can be of the type of aggregate message kind, and then we return function that is just schema.annotations aggregate message kind can be a type message kind, and we should be up and running. Yeah, perfect. As command is where we don't care about that. Yeah. Maybe we can also say export function get aggregate message kind from schema. Okay, that is this function. Okay, and this will return an option of get annotation. The kind of video annotation is now aggregate message kind. Yeah, so now that can be an aggregate message kind. Perfect. And this will just return the annotation. Perfect. Okay, that's perfect. And this function basically extract the annotation from the schema. So get areas from schema annotation mainly. And there's with aggregate message kind of annotation. Perfect. And the option model isn't needed anymore. We can go here, and now here we also say dot pipe aggregate message with aggregate message kind, and the message kind is this. Okay, so this is of type query, and this is of type comment. Perfect, perfect. And now that we attach the annotation into our schema, we should be up and running. Yeah. So let's write maybe some tests to see how things work. Let's go to our dummy tests. Maybe we can use the scratch in here as tests. In here, we'll do like this. Okay. Yeah. Not from aggregate root, and is at template domain. Yeah, we need to change the name. Yep, domain. Yep, I don't want to type in one of these. Aggregate message. Okay. Aggregate root, sorry. Okay. Maybe we can also change those. Let's see. Yeah. Okay. These are the things that are sketched out by the Create Effect app. Maybe instead of app template, let's see. A template. Let me find just in the JSON files. Template domain, template domain, template server. Yep. And I think that all of those can be replaced with sp. Yep. Okay. And let's see other kind of PNP lock. Okay, we will do that later. Yeah, that's correct. Yeah, that's correct. Yep, that's correct. Yeah. So let's replace everywhere. Okay, and then we will trigger again a npm install terminal. Yep, npm installed. Okay, everything up to date. And now that everything is up to date, we can go back to our here, our test. Okay. Okay, let's see now. Okay, why don't you fail to load? Fail to load the URL. Oh, domain aggregate group. Yeah. I see why. We need to recreate our entire node modules, and there should be already into a clean, yeah. So we can run npm clean. Okay. Let's also update our effect dependencies, maybe. I think that they are listed, already listed everything as latest. Perfect. So maybe we can just remove our pnpm lock, yeah, and install again. So we update everything. Okay. Already up to date. Perfect. And here we should our other packages, yeah. Now let's try to run again the tests. Why don't you like me? Again? So let me check. Let me check again. Him here. Let's test again. Oh yeah. Okay, now it works. Okay, so let's see. It should check that should check the type of the message, and we expect that please import the aggregate message module in here. Okay, and we expect const is query that aggregate message get aggregate message scan from schema and read product name. This will return an option. So we expect option if I have his query tag the sum. Let's try it out. And it won't. And that's expected. Because if we take a look, we put a breakpoint in here. Okay. If we take a look at this object and we take a look at the AST, so if we say something like read product name dot AST, this is an object And in its annotation, we won't find our custom annotation. And that is because they are into our from annotations. Here we have a read product name encoded side. Perfect. We have property signatures. Here we have an ID. And in annotations, here we should have two type encodation. Yeah, should have ID, type refinement. Oh yeah, it's a refinement. Yeah, annotations. Here it is. Yeah, here's our annotation. Yeah. So we need to traverse the entire schema to get up to this annotation. So let's try to build a function that does exactly that. So we will keep that get aggregate methods kind from schema annotation. And then we will say something like export function get aggregate message kind. And we will take a schema as well, but from AST maybe, AST. And we'll say that we will take in an AST. Okay. And we will say that if we will try first to look into the AST of this member and say that const has const is query, or maybe message kind equals AST get annotation. It's the same line that we have here. In the scan annotation type ID, we pass in the AST. That's perfect. Okay, this will return an option. Okay, perfect. And we will say that if message kind, if we found an annotation, we will just early exit. So we will say if option is so we need to import option, import everything is option from effect option, and we'll say that if option is some message kind, we will return message kind. Otherwise, we need to switch based on the AST.tag. And here we need to have some kind of logic in here. We will say that in case we found an any keyword, a begin keyword, a Boolean keyword, we will return option.none, because we attach that annotation to a UUID. And so if we find one of those kind of tag with failing, there are many others like enums, literals, and etc. Number, keyword, etc. Maybe we can write the other case, which is case. It is type literal, I think. And AST, yeah. And if we have a tag, ID in AST dot property signatures, this should be, oh no, it's an array, yeah, okay. So it's an array. I thought it was, yeah, so if it's an array, we will basically do return import everything as array from effect array. array, find first. This keeps, yeah, it's not find first. It's options. We have filter, I think. Yeah, that works for only one. Yeah, we need to basically look up for a function that, given a list of members of effect of an array, we will find the first that is sum. So let's go quickly to the F5 APIs. Okay, let's go to docs. Let's go to API reference. Yep, F5. Have they been moved? API reference. Oh yeah, they have been moved. Yeah. Yeah. There. F5 array. Where have they been? Oh, API reference. Yeah. Effect. Okay, so for the array, or maybe the option module. Option module. Yeah. We should have all. Yeah. Option, it doesn't have option, what is this option? If I tap with some, we want to select. Yep. But we also have option. Yeah. So let's try to use. Yeah, that would run for. Yeah, let's do something easier. Let's say something like is 10 or closed for the signature of EST bring to the signature. Yep. And we'll say we will get an aggregate message guide from EST property signature dot type. And we'll say that if result option is some result, we will basically return result. Otherwise, we will return option dot none. Okay, so what we are doing in here, get it from scan. Yeah. Oh, yeah. This is obviously option dot option. Again, this is kind. Yeah. Yep, that's fine. And we also need to, in case we don't manage that type, default. Okay. Now it's fine. It's not complaining anymore. We don't need the array modules for now. Yep. So this function will traverse the schema est. In case we find the type literal, we'll go through the property signature and find the one we want. If the one we want has that, we're fine. So let's go back and see what kind of things we need to manage. We need to manage also the transformation. Okay. And the transformation we need to do, I think, the same thing both on, both on the from and the to type. Yeah. Okay. So case transformation. we will do return. And here we can do something like get aggregate from ast.from type option dot alt or else get aggregate message kind from ast2. That way we first try to extract from the encoded type. If we don't find anything in the annotation on the encoded type, then we will jump into the encoded side. Yeah, that works best. Yeah. And then we have, let's see, the file transformation. Type literal, we already done it. Property signature, yeah. Refinement, we have refinements, yeah. And refinements are really easy because what a refinement is in effect schema is basically just a check over the structure. The structure doesn't change shape in any way. It's only an additional runtime checks. For example, a UUID is a string that has some kind of format, so you can put a check on the format. What we do is just get aggregate message kind pst dot, and that's it. Yeah. So now if we try to run again our tests in here, okay, we are still failing. Let's try to see why. Okay, this is normal. Okay. Let's continue the test. Yeah, this failed. Let's try to debug it. So aggregate message. Okay. Here. Perfect. We run again the tests. In here with the bug on. We should jump. Why didn't you stop it into the log? Did I mess something that I called? Oh, I called the completely front function. Oh yeah, I called the annotation version. Get from st, and for now we'll do that like this. St, yeah. Let's check it. I can go run again. Let's run again the test. Let's see. Okay. Okay, now we are getting the message kind. It's not in this kind of annotation, which is a transformation. So we step in. The message kind is not in here. This is what? A type literal. Perfect. We have many property signature. This is the property signature of the tag. So we want to find it in here. Okay. I will exit. Yeah. And then the next one is the property signature of ID. We should find the annotation in here. So let's check the function if it works. Here. Oh, this actually now returns some instead of none. So this now exits with the correct value. Yeah. Yep. And now our test has passed. Yeah. Let's rerun this. Yeah. We passed our test. Okay. So maybe let's rewrite the test in a way that's more readable. Everything as option from effect option. So we expect this. Option is sum. Okay. And we're gonna name this to message kind. And we also expect message kind to be equal, so to be options dot sum query. food equal. And here we expand with skirt. Yeah. Okay. So we expect that the message kind is present and it's of type query. So let's run everything again and we pass again. Perfect. But maybe get aggregate message kind from EST is not so good and useful. So maybe here what we can do is first, here we are reusing the same, oops, sorry. We are reusing the same code, so maybe we can just do something like here, return get aggregate message kind from AST schema.ast and rename this to get aggregate message kind. So now our usage becomes more clean because we can just pass in here message kind and read product name. Okay. But if I remember correctly, that means that we can also write the same for a comment, just to be sure that we respect both the things and maybe two different tests, maybe. So here, query, and this is aggregate message, and rename this was aggregate message. Perfect. And here, query, it should check that our message is a query. The same goes for common, and it's change product name, comments. You should check the type of message. Yep. And here, if we run our tests again, server, clear, download, perfect. Yep. We should be up and running. Perfect. Did we test crashed? It seems so, yeah. So refresh everything. What? Test. Oh, yeah. I killed the suffix. Dot test. Okay. Now you should see their main tests. Yeah. Okay. And they pass. Yeah. Query. Perfect. Those passed. Perfect. Okay. So now we have find a way of defining messages. The last kind of message I described last time was an event. And an event, I think that I want to describe that not as a target request, but maybe just something like we want to change the product, we want to read the product name, change the product name, but we also to describe that the product name changed. Okay. So I think that I will use target class instead of that. Okay. And target class is easier because it will require just the payload structure. And maybe we can have something like full name, name string, and new name is that. Okay. But I don't want to use a comment. I want to define a product aggregate.event That's perfect. And now maybe we want to add query command for event. And we will here create a new constructor. Maybe we can create an interface for that. Yeah. Maybe interface on aggregate message constructor on aggregate root names of string, and this constructor, yeah, the stands maybe the stand string, and this kind of signature will take in payload stands schema struct fields, and will be basically the same of this. Yeah. Perfect. And now here we can say aggregate root name query command, and also event here. And we have to do the same thing and say that event of type event. Perfect. And now here product changed. Yeah. Type event. Perfect. And here goes the same for an event. Product name changed. Okay, let's run our test again. Perfect. Everything is okay. Up and running. Okay. So I think that with this, we basically closed the topic of how we want our messages between the client and the server to be defined. And as we described last time, the commands, the queries will read data from the backend, the command will perform actions on the entities in the backend, and the event will be used either internally by the server to persist what happened, or by the this event source HTTP request to stream things that happen on entities and show them on the user at the user. Okay, so we have now defined our messages. Now I want to move into defining the behavior of the product. And the behavior of the product will be something like when I receive a change product name request, I will perform some checks first. And then after I perform some checks, what I will do is persist an event that the product name has changed and then update my internal state. So I'm fine with this module. This module is not needed anymore because in the end, we moved that into the aggregate root. Here it is. Okay, so let's see. There is one last thing that I want to add in here, and it is the causally schema.option of schema.uuid and correlation ID option schema.uuid. And this function, these members will be used to create a chain of the events and the comments and whatever that happens in our system, because this ID will be the ID of the single message, but that single message may cause an event. So the event will have in the causation ID fields the ID of the command received that caused that event to happen. And I want those fields to be option, and I don't want them to be mandatory. So I don't want to type schema and option.none every time. I want them to be by default none if if not provided in any way. So let me just check something. Yeah. Yeah. Okay. And we can do that by using schema dot parallel with. We say that we have an optional UI ID and we have a default, and the default is option dot none. And we need to import the option module as always. Option from in fact option. Okay. And the same goes for the other field. Yep. Let me just check one thing real quick. If you okay. The thing is that I'm thinking about is that we can do something like this to put an optional and say that the field is optional, and if not provided, it will be defaulted to none. I'm not sure if we can do something more clever. We could hypothetically use some of the properties of the environment to automatically fill that, but maybe let's do that later. Let's just me check the. Okay, and then so this will return a different kind than the one that I defined it. Yeah, so we need to update that as well, because now this here, yeah, we have added two causation ID, which is schema optional with and schema dot option type of schema UUID, and we have a default from it, which is basically option dot schema, sorry, type of schema option type of schema UUID thing. Oh no, it's a string. So schema with touch option string. And the same goes for the correlation ID. I missed one. Okay. And now, what are you complaining about? Causation ID option default. Your option is not to fill string. Oh yeah. You want. Yeah. Default should be a lazy that returns that. Yeah. And what's not okay by you? So let's see. Option with default is not assignable to type. Yeah. None is not assignable to type option. Six on to type A. Let's do the quick and dirty way. And A equals never. Oh, because that's never. Yeah. If I do that like that. That's the beauty of TypeScript. Sometimes you completely understand what you're trying to do. Sometimes it tries so hard but fails so badly. I need to do that because the secrets are a little different. If I don't fix the argument to string, it will complain that it can actually receive a function that converts anything into anything itself, an option of anything itself. And that's not what we are describing. Yeah. So now we have added causation ID, correlation ID. And that's great. I'm unsure if I want to also touch in here information about, for example, the user ID that caused a message. Maybe not the access token, which is definitely secret. But yeah. Yeah. Now we should maybe add a test that says that by default, the aggregate root should be filled. So that means that we want our APIs to be in such a way that we create a message and say that, for example, is change product name, Lake. We want the new name to be new product. We want the ID to be the message ID. We want the aggregate ID to be product ABC. But what we are testing in here is we expect message dot aggregate root to be or to equal product aggregate root name. That's the thing we want to test. Oh, we said we wanted a UI ID, and guess what? We didn't test UUID in our test. Yeah. So maybe let's just stick with non-empty string. I'm not sure if we will use actually UUIDs or whatever. Let's say that non-empty string. And run test again. Okay, now it's passed. Perfect. Okay, so I think that with this, I am pretty confident that this is what we want. So now we need to move into defining the aggregate behavior. And I want to define the aggregate behavior by first having a list of basically an event journal approach. I want a journal that has a list of events, and I want to define how to handle a specific comment. And handling the comment will be basically checking the database or whatever, or the message itself if the comment if the comment is applicable, and then we'll perform the work. So let's try to scratch that out. We have our aggregate, we have change product name, and we now have also product name changed. We can copy from here in our scratch file. This is where I always scratch things to try them out. So we may start by having something like const behavior. We want product aggregate dot, or maybe make a behavior, make behavior for the product aggregate. And we also need to say which. We can think it in two ways. I think we can see which kind of events are handled, are managed by the product aggregate. Yeah, I like that better. Yeah. So we can say something like function make made an event sourced and aggregate. And we want to first pass the aggregate, which will be aggregate root to be precise. Aggregate root, and maybe this like pay extends aggregate. This is the aggregate root. Then you also want a list of events that happens on that aggregate root. Maybe we will have punks, the event rules aggregate parts of A, and we'll return later something. So let's sketch out this interface. This will take A extends an aggregate root at string. Okay. And now we have this and these. We will have things like the events. Or maybe we can pass in the events. Let me try to sketch out. Const product journal product aggregate journal equals make an event source aggregate of product aggregate. And this is fine, perfect. And now I also want to pass in a list of events that can happen on that So will be something like, maybe, let me think. We need to first have a type that describes that. So maybe in here we can say like export namespace, aggregate message, export type any for aggregate. And here we pass in the aggregate. Aggregate root from the aggregate root. Aggregate root dot aggregate root. I want to define a namespace in here. Export namespace aggregate export type all equals aggregate root or string here. And why I do this, you will see this kind of pattern everywhere in the effect code base, and that allows to do things like here, say that the aggregate message extends aggregate root all. And I can also build some type level utilities. For example, export type name of A that extends all, and I could say that A extends infer credited infer name, and we want to return the name core never. So that means that in our any for aggregate message, we can extend and say that it is basically anything that has aggregate root, and that's aggregate root name held A. Yep. So anything that extends any for aggregate. Yeah. So now we can do things like event equals event extends aggregate message any for aggregate A event. Okay, perfect. And now if we say product name changed, it's not multi-type. Oh yeah. Because. Yeah. That makes sense. Because this is not the actual instance. This is a class that describes the message instance. Yeah. So here, instead of just doing that, we could say something like, we want any schema that has an aggregate root field. Definitely, yeah. Okay, so let's try that out. So we have comma A. Can we let me check? Can we do something like that? Also, what time is it? Oh yeah, it's almost time to finish the stream. So yeah, maybe we can check out that later. But the thing I want to be able to express in here is basically the ability to limit the kind of messages I can put in here, and they can only be of the aggregate I'd put in there. So here, For now, we have only the product aggregate, but let's say that we also have the member aggregate of members here. And maybe we have an event of the members that is like member joined in here. Do we need to change this? It's member aggregate, not event. And joined maybe won't have any arguments. What I want to express is that this should work and this shouldn't. This should fail because we will say member joined. This should fail and this should work. So if I remember correctly, now schema here, a schema now also has an encoded and a time. Maybe we can say that we in here anything that has a property type that is like that. Okay. And that means that we should be able to take in whatever. Yeah. And whatever has a schema where the type it goes into that. Yeah. Why are you complaining about number? Type of derivative treat is incompatible with result. Type string is not some type never. Oh, did I write wrong the type utility? Let's say type a equals aggregate treat dot aggregate dot name all. In this case is variable aggregate. And this should be, oh, we messed up something. Oh, yeah. That's the error. And after we fix that, yeah, now we have what we want. Yeah. Now it says that a member joined event is not assignable to of type products. But if I say member aggregate, now they perfectly match. And now we can use that. Yeah. The only thing is that I want that to be an array, a read-only array. And events. And that is because I want to do things like member join. This should fail. Perfect. But let's say that we also have another event like product name change. Let's say that we also have product when we want to product deleted, maybe discontinued instead of deleted. Name product discontinued. Okay. And this will have a reason, which will be a string. Product discontinued. here, now we should be able to say predict discontinued perfectly. And now if we, for example, return, and in here we return event number. Sorry, just event. Event should be, did I mess up with event? Okay. Event. Yeah, that is a tuple. Perfect. And if we just say number, now we have a union. Perfectly. We have a union of the kind of events that can happen on our aggregate. Perfect. So we know upfront the events and now the last thing is that we may want to perform some work upon an event happening. Something like update aggregate state that given an event, it can be of type events number. Not sure why capital N. Okay, that should run on effect. Well, we didn't import effect yet. Import looking as the effect from effect. So it's an effect dot effects that can be, well, can return nothing, can error with any value you want, and can require whatever you want. So we need to add those type parameters on the error and the requirements, and we will return an exact dot. Right here. Effect dot effect of void er. And the event source aggregate, to be honest, can't really fail because if an event happened, we cannot fail in updating the state. And if we say if it's something file, so yeah, I prefer to do that. And then let's just do this for now. It will obviously complain because that's not what he wants. Or this one is not required anymore. Okay, but now we should have something here that given an event, here we can do things like if the Twitch event dot tag case product name change return effect log info product name now is, and we can say like event dot oh, I see. We have little error in our typings because here we have type of product name changed, but we want actually the instance of the type. So it's schema dot type of event number. And this should spread. Yeah. So now you can see that it's just product name changed, not type of. So here we also have, yeah, we have our information, such as the specific product ID, the new name. Noun is new name, for example, and case return effect log info product with ID event dot aggregate ID is now discontinued. Okay, so this is kind of the way I see that we will define the state of one of our aggregates in a very event journal way. And this is the journal that will take in the aggregate, the events that can happen, and a function that will update the state given the event. But obviously, just an effect is not useful at all. What we need is to have functions that, for example, will append an event into the event journal. So let's try to sketch that out. Event source and aggregate. Right. And this event source aggregate can be of this type. And this is the kind of events that can have. And we'll say something like append an event of type events. And this will be an effect. Never, sorry, that with no result, never, and without any requirement. Yeah. So let's try to change the return type of our sketched-out function. Let's say event source aggregate of a event schema dot type of events number, right? Let's see. So now this is an event sourced aggregate of products. Okay. Yeah. Just not happy with that unknown. Maybe I put it, oh, it's event, not events. Yeah. Maybe it's better to call it events because it's actually a tuple of the possible events. Yep. No. Yeah, look at this. By just looking at the type signature with this kind of API, I'm thinking we can see that this is an aggregate, an event sourced aggregate of type products, and these are the kind of events that can happen. Yeah, definitely. To be honest, maybe we can also skip altogether the aggregate to the type level information, because right now we only store the name, and we have that as well also on the actual type of the message. So yeah, here we know the aggregate root name. So yeah, maybe that's too much. But that means that we now have an API where product aggregate journal dot append, and here we'll take an event. Perfect. And we can make it so that appending the event will happen immediately. And after appending the event, maybe on the same transaction, because we will use just an SQLite as database with an events table. And we can make it so that in the same transaction, we append the event and we also perform the queries to update the state. We can both keep an in-memory state and also maybe perform actual queries. And there are pros and cons of both approach, I think. I think that if we just keep an in-memory data structure, like for example, an object, we can actually forget about constructing specific tables for that entity and just describe that with a schema. Whenever an event happens, instead of allowing to run an effect, we basically here provide a way to return an updated version of that in-memory object. That way we can reconstruct the object by basically deleting the stored representation and recreate that. But yeah, I think that we will discuss that later on more next time. For now, I think that I accomplished what I wanted to finish today. I wanted us to start a little working on the backend server. Unfortunately, we didn't make in time to do that. But yeah, we still did quite a lot of work. And what can we also check out? Let me see. Here, maybe we can investigate more. Let's see. Let's see what we can do in here. We can do things like saying that we can either allow to perform queries in here or just update the memory structure. Yeah. Maybe we can look out if we find a better way to construct the aggregate than this one. For sure, we can move that into something like product aggregate dot behavior. Yeah. But the thing is that I would like, this is how an event is persisted, but I also would like to other APIs that allows, for example, to say when I receive a command, decide if the command is valid based on the state of the entity, and eventually discard the command if that wasn't right. But yeah, or also persist commands that needs to be sent to other entities. Yeah. Yeah. I think that for today, that's enough. I think that next time we will invest more time in defining the behavior of the entity of the aggregate. So a quick recap of what we did today. Today we finished our DSL for defining queries, for defining comments, for defining events, and we also provided function that, given a schema of one of those, decided and allows you to get which kind of message it really is. And we also started scratching out the potential API we want for the event journal of an aggregate. Maybe we can rename that to event journal. Event journal. Yep. And then this can be product event journal. I will invest more time in thinking what we want to do offline. And unfortunately, my time is running out. And thank you, everyone who joined. And I hope to see you next time when we will finish our behavior decision. And thanks to you again, everyone. And have a nice day at the affecting. See you, everyone. Bye bye.